Back in January, I posted this on my blog, kind of a list of microcontrollers that I would like to work with over time. Many of these are microcontrollers that I picked up inexpensively off of eBay, maybe a batch of old 8-bit microcontrollers, or maybe some that for whatever reason were being cleared out somewhere. Not a whole lot of rhyme or reason why I've selected the ones I have here, other than I was looking for a variety, and still am. As I find others I might add to this list, which I've recently done. For example, this STM32 number 8 I've added to the list. Now, some of these, I have a dev board built. I've successfully been able to compile a program, flash them, or program them and test them. Some of these I've simply designed the PCB, but haven't gotten to the point of actually assembling PCBs or programming them. And some of these I've worked with quite a bit more, like this Cypress PSOC. I've had a fair amount of time I spent working on those on previous projects of mine. And then along the way, it was suggested maybe take a look at the Lattice stuff, and I started working on some ICE40 stuff and in the middle of that also. And I've added some other older FPGAs that I'm just playing around with. Again, really just for the educational opportunity there, more than trying to turn these into some ultimately super useful type of MCU or FPGA or whatever it might be in my projects. Really just trying to learn a little bit about different MCUs and the different environments from these different vendors, whether they're old environments or relatively current development environments. Also, a little bit ago, I posted a video talking about this ICE40. I've put together a board for it. This is specifically a 256 ball BGA, so it's the CT256. That's this here. And I put this little test board together. With that, I have a bunch of little utility boards to go with it, maybe one for outputting VGA and some static RAM, that type of stuff. But one of the boards on here is this little board up here, and this is for an MCU, and it's a TI TMS320. And in this video, I'm going to walk through that board specifically. I have received all the rest of these in, so I will be getting back to this ICE40 and trying to get this BGA soldered to see if I can do that successfully or not. But this little board I built so that it can run independently without this FPGA board. And today I'm going to walk through this in a little bit of detail. So if I flip over to the part specifically that I'm using, this is the part I have. So I picked up a small batch of these. And if I look through, the specs for this, I can see it's a TQFP package. It's a 64 pin. I can come down here and see that it's 60 megahertz capable and read a little bit more about it here as I scroll through it. It is a 3.3 volts, so 3.3 volt that it takes for its supply. And it's got, a fair amount of capability inside of this little package. And if I do jump over here, I do have the data sheet up for this and a little bit more information here on the screen. So this is a TMS320F28035, and then the specific one I have is the 5. And so I can scroll down through some of this documentation, and I can see what are the different packages and body sizes, things like that. And an architectural, overview of this MCU. And it is using this C28X processor or CPU. So that's something for me to also learn a little bit about as I get into this. So I can get in here and I can look through this in a little bit more detail. So here's the 28035. I'm using this 64 pin package, and I can just kind of see, it has some onboard flash, this on-chip SA RAM. I'm not sure how that's pronounced, but I'm going to say SA RAM. And I've got a boot ROM that is on it. I believe that's programmed by TI and read only. And there's also some one-time programmable ROM on there that I can work with, which I probably won't do anything with. But then there's all this other capability set that I can work with. And I have up to, it looks like 33 GPIO that I can use as I get into this. If I keep on coming down through this, I can take a look at the package. So here is this 64 pin package that I'm working with. And many of these pins have shared purposes. So maybe there's some analog type of input or comparator type of pins. There's some GPIO. There's power pins, of course, things like that. And then there's a larger package version, which I don't have and I'm not using. And then this goes through all the different signals coming out of that I could be working with. But this is the one that I have put together a board for and basically received that in recently. And then I thought what I would do is just kind of walk through that and show you what I have. So if I take a look, here is the actual board. Maybe what I'll do is just pull this up in the design tool I'm using. And if I pull that up, here is what this board looks like. And maybe I will just hide some of the fills. There's stuff we don't necessarily need to see here. So let me just get some of this out of there. So this is the board. I've got and I can go to a 3D view for a bit and kind of flip around this. But I've got a power connector coming in the upper left. And this is the same standard power connector I'm using on all my projects. So it's going to bring in 5 volt. And from there, I do have one of these buck regulators. So this is an SY8009 BABC. This is a 2 amp buck regulator. So I'm going from my 5 volt down to a 3 volt with it and this inductor right after it. So a very small footprint and some capacitors. I have some bulk capacitors coming in if I want to use them. And I actually, you'll see here when I get to the board that I'm using, I didn't even bother to populate these because I had some others that were plenty sufficient, I think. So 5 volt in, get my 3 volt from this. Alternatively, instead of pulling the power from this connector, I can pull the power from this connector, which will go to that FPGA board when I get that up and running. And then I have jumpers that I can just flip over to say pull the power from this instead of from this connector up here. This connector will bring in both 5 volt and 3.3 volt. Then I have the actual MCU itself, so you can kind of see that here. Around that, let's see, I've got some things like capacitors and resistors and ferrite beads. So if I come back, you're going to see some of those in the schematic here. Basically these, what's called for, I guess, in the example I was working with is this, and I can flip over and pull that up real quickly. So these are these ferrite beads, 60 ohm, and I didn't have the exact ones. I had some that were pretty close to it that maybe were 50 ohm ones instead, and I used those. So you'll see some of that as I am looking at my actual PCB. And that'd be on some of these power lines coming in. In addition to that, I do have an external crystal so that I can run whatever speed I want instead of the internal. I believe the internal is a 10 megahertz, and out here I can supply up to a 20 megahertz, and then I suppose, is it with PLL that this can run at 60? So if I understand that correctly. I've got my programming header sitting over here. I have really just 8 signals off of this that I run both to the connector to go over to my FPGA board plus to this connector just to do some simple debugging, just to make sure that without even connecting to anything else, I can validate, can I get these 8 signals to work or not. I do have a PS2 keyboard connector so that I can hopefully process keyboard input with this MCU. And this here is just a simple little voltage level shifter to go in between the 5 volt keyboard type of signals to the 3.3 volt for this MCU. That may not be necessary, and there might be easier or better ways to do that, but I have a bunch of these levelers, and I kind of wanted to test how that's going to work anyways, so this is just a good way to experiment. Now, as far as the layers of this real quick, let me get back to my PCB and go to layers and pull that up. You can see it's a 4-layer board. So signal on the top and bottom, and then I have a full ground and a full 3V3 or 3.3 volt. So that's how I have this set up. And let's see if I'm missing anything. I do have LED indicators here to show me that I have my 5 volt and also a 3.3 volt. And that those indicators for the 3.3, I am running through a transistor so that once the 3.3 is turned on, it enables the transistor, and I have a nice 5 volt to drive that LED. So these two LEDs will be the same brightness, but one's for 3.3 volt, one's for 5 volt indicator, just to show that those power rails are working. But I think that's about it. I do have some, I guess, resistors on the bottom. These are pull downs for the analog lines. I don't know if I even need them. I've not populated them at this point, but I did put them in there because it seems like on the analog lines, especially if they're unused, I believe you're supposed to pull them down to ground. And if I go to the schematic, maybe to point out a couple of things, I've got all my power, and I'll try to post a version of this schematic now that I know this is relatively working as far as I can tell. I'll get this posted up to my GitHub. But maybe some things in here that I might call out. I do have some pull-ups on some different signals there, and I'll come back to this. There's an issue that I haven't figured out yet, and I do have pull-ups to maybe help with that. I do have that level shifter here that I'm using. Here's all of those resistors for the analog lines going to ground. Here's my PS2 keyboard connector, bringing in my PS2 data and clock. But then I'm mapping a bunch of these GPIO signals to go through that connector to my FPGA. So I'm going to have 16 data lines, and then I have 20 address lines along with a clock and read-write signal. So the goal there is that from my MCU, I can communicate with my FPGA in a parallel manner if I choose to do that. Maybe I'll end up using SPI or something else, but again, that's a bridge I haven't gotten to yet, and I'll worry about that later. But at least hoping to get a whole bunch of signals out of that connector, this bottom connector here, to go to my FPGA board. And that FPGA board, again, back over to here, would be this one right here. So eventually power will come in here. It'll be fed up to this MCU board, and the MCU can take in keyboard, and it can hopefully communicate with the FPGA through those, really through just the top bank of this FPGA, still leaving me 3 other full banks to do stuff with. So if I look here on my workbench, so this is the board I actually assembled, and I'd say for the most part it went just fine. I did make a couple of minor changes from the schematic, and you may or may not be able to see this on this board, but there is a tiny little bodge wire that I put in here because there's one of the signals. There's a couple of signals I needed to pull up with a 2.2K resistor or something close to that I did not have pulled up. So one of those signals goes to a pin on that, so I just went to a nearby 3.3 volt and did a pull up. There's a tiny little 0402 resistor just on a leg of that. So that's giving me a pull up there. And there's another signal down here in the back. You're not going to be able to see this in the video, I don't think, but I put an 0402 resistor there and tied it to a nearby 3.3. So there were 2 lines that I needed to do pull-ups on. And the reason I did that is there are a couple of signals that the MCU looks at when it is initialized to determine where it boots to. If it basically boots to reading the flash, internal, or something else. And that part I don't have working quite right, and I'll talk about that here coming up. But these pull-ups I think need to be there, so I had added those. So those are 2 modifications there. But other than that, I don't think I really changed anything from the schematic that I had put together. Now, to get this working, a couple of things. I've got this just same old power that I've been using in my videos, so I'm going to go ahead and plug that in. I have about 5.1 volts coming to this, and I can just toggle this on or off. And for now, all you're going to see is these 2 power rail lights show up that they're getting their power just fine. So I'm going to pull that off to the side and I'll be toggling that on and off, but you can just pay attention to these power lights here when you see those on. This is getting power. So then I've got to figure out how to program this, and the programmer that I picked up was an inexpensive, I'm sure this is a Chinese knockoff of a TI XDS 100 V2 is what this version happens to be. I think there's a V3, there's maybe some others. But this is basically a USB connection to my PC and then a ribbon cable here. And the pinout of that ribbon cable matches what I've set up on my board here. And so basically I can come in here and get this plugged in. And in my case, I'm just going to plug it in like so. Okay, so at this point, I have this ribbon cable coming from this box to this header on my board. And looking at the schematic for that, for this programming header, what you're going to see is it looks like this. So pin 1, which I have down in the corner and I just marked with a marker, is my TMS, and then I have TDI, and then I come down to pin 7, I have TDO and TCK. So basically my data in, data out, select, and clock. Then there's a reset signal that is also on the bottom edge, pin 2 here, and then a bunch of grounds, and then some signals 13 and 14, which I don't think I'm really doing anything with at this point. And this is one of the pull-ups that I added after the fact, was this TDO line as a pull-up. And that has to do with the boot select. That pin is red during initialization, and it needs to be high to boot to the internal flash. Along with, there is one other signal that it looks at, which is this, let's see, GPIO 34. So I added this pull up right here. So those were 2 of those 0402 resistors I added after the fact and then added to my schematic. Now, tool set wise, what I found is everything I needed for this is freely available, at least in the US, from TI, Texas Instruments. There's some export restrictions on some of it. So if you're outside the US, I don't know if you're able to download these or not. But I did document that over on my blog. So if you go out to my blog and find this post, MCU fun, you can scroll down to this specific Texas Instruments. And in it, I do go through the basic steps of getting the development environment set up. And then I have some links for resources. And that should get you to everything that you would need to be able to get up and running, to download really a couple of things. There's this Code Composer Studio, and there's 2 versions of it. There's this Thea version and well, not Thea version, just Code Composer Studio. I started with the Thea version, and it's supposed to support this MCU, but all the documentation, all the videos, everything I was finding was using this other, I'm guessing it's a slightly older studio. It doesn't look as new and fresh as the Thea. The Thea looks like a really nice IDE. But I'm using this Code Composer Studio that you'll see here in a second. And then there's also this C2000ware, which just gives you access to sample projects and board schematics and all kinds of things. And then there's also a compiler, a C2000 compiler that you'll need if it's not installed with the Code Composer. But I did install all 3 of these. And then after I installed them, it prompted me that there were updates, and I did the updates, which seemed to initially break some things, and I had to just tweak a couple of paths real quick to fix that. But maybe let me jump over to the first piece of software here that is this software here that is Code Composer Studio. And resolution-wise, this is probably going to be hard to see, but I'll do my best here to zoom in as I'm editing the video, but not trying to go through this in detail, but just kind of show you some of the basics of this. So in this tool, you can go in and create a new project. And as you go through that process, you can open an existing project. or import an existing project. And that's what I did to get started. There's a sample LED blink type of sample project that I imported. And over on my blog, I just show the basic steps to open a sample project. So that should say to open a sample project, and I walk through that. Okay, I quickly corrected that typo. So let me get back down to that. Okay, so to open a sample project, and then I kind of go through the steps of opening up this sample LED blink. So then once that happens, you'll have something like you see here on the left, and one of the files is the actual C file. And let's see if I can zoom into this. The basic shortcuts I'd expect for zoom don't work. So I'll have to look into that later of how to zoom into this. So I'll try to zoom in as I'm editing the video here. But as I scroll down through this code, you know, they're including header files, in this case, some DSP28X project. They're going to set up an interrupt and basically a timer. And when that timer essentially is triggered or fires, they're going to come down here and toggle one of the GPIOs. Now, their sample just did this on one single bit. I changed their sample to go to a different port and pick 8 bits. So I've got 8 bits that I'm setting up to do this, and then I'm toggling 8. So on my little board here, what's going to happen is I'm going to come down to this header here and toggle 8 of these on and off. And on these projects, I've been using this little LED header that just takes those 8 signals and makes them visible easily. So I'm just going to, you know, click that on there so that I can see what's going on here as I program this. But when I'm done with that, I can then turn around and I can do a build. So if I want to come up here, I can do a build all. And I would, of course, expect it to finish without errors. And in this case, it did. I really haven't changed anything, though. So it's just saying there's nothing to be done. But this is built. Now, over here, if I want to now get this running on here, I need to get power applied. So I'm going to go ahead and turn on power to this board. And so there I've got that turned on. And maybe I'll just set something behind this for holding it up a little bit for the glare. Okay, so now what I can do from this is I can tell it that I'd like to debug, and I can actually walk through the code line by line, or I can just load up, and I'll just load up. And so this comes and goes through this configuring the debugger, and then it should start running on my board. And you can see that it's running, so I'm just simply taking those 8 I/O and turning them on and off. So that all seems to be working so far. So I can come in here, I can use this software to, you know, put together a project basically. So I have a lot to learn here on the specific functionality that I'll be working with, you know, what are, you know, how to enable interrupts, disable interrupts. There's just a lot in the development for me to work through. But the basics that are here so far don't seem to scare me. I think this is definitely learnable. So I've got time to spend learning this. You know, I've done Arduino stuff in the past, and I'm looking through this and not seeing things that are too crazy from that. So then that has basically programmed it through here. Now, if I do want to debug, I of course can do that. So I can say debug. And basically, it's going to stop on the first line of code. And so now I'm in this void main, and then I can go ahead and come up here, and there are buttons then for the step over, step into, step return. So let me just do step over, which is F6. So I'm going to use the keyboard here, but F6, and I can work through this. And I'm just going to hit a bunch of F6s. And kind of keep going until I get to this. Now I'm stuck in this loop, and then let's just see that interrupt code. Maybe I need to set a breakpoint down there. And so can I I'm learning this on the fly here. I've not done this before. So I put a breakpoint there. I'm sitting right here, but I'm going to go ahead and tell it to continue, which is this one. So now it's running, and I think it's now down here. So if I want to now, I can go back and do this step over F6. And you can see that as I'm doing this, those LEDs are basically turning on. And it looks like the keyboard shortcut to keep running is F8. So I just do an F8, and then I get to it again. And then again, I can do my F6 and work my way through those. And you can just see the way I've got them ordered is kind of every other. That just happens to be how this header is showing them. That's not a big deal. And of course, I can map these however I want. But I'm now interactively debugging as I go through this, and I can see that being reflected over here. So I'm going to just tell it to resume. Let's see if I can get rid of this breakpoint. Let's see, that actually put 2 breakpoints in. I'll delete them, and then I'll hit F8. And so now it should just do its normal running, which it's doing. But that all is good for me because the development environment's working. I didn't have to do anything too crazy other than download this software, get it up and running, but that was, it seems like well supported. I'd say the documentation from TI is extensive. The content I found out there talking about this specific MCU seems like there is a lot of it out there. There's a lot of YouTube videos. There's a lot of other content that I found. So it seems like this specific TMS320 and this version of the processor, the 28035, must be used enough out there and must still be active. And I think it is listed as an active product, if I'm not mistaken. If I go back over to TI's website, it is listed as an active part. So this is something you still can actively purchase and use. So I have a lot more to learn here about this. Now, one problem that I've not been able to resolve is, I guess my expectation is at this point is that the flash has been programmed, and I would think that I could take off power here, get rid of my debugger, and when I turn it on, I'd expect that program to run, but that's not the case. And so I don't know why that is yet. I have to track that down. A couple things that I can do. I did check in the documentation, and over in the documentation, get rid of that, I can pull up information about the boot. So there is some configuration for the boot mode, they call it. So if I search for boot mode, and it talks about how these pins select a mode. So there's a GPIO 37 and a 34 and this active low reset. I think what I want is what's called Git mode, and it says with Git mode, that's to boot to flash. And so this needs to be high, which I put a pull up on. This needs to be high, I have a pull up on, and this needs to be low, and I have a pull down on that. And so those, when it's turned on, should be set correctly. And I have looked at it on the scope, and they look like they are being set correctly. But it doesn't act like it's reading flash there. There is this other tool that is, again, a free download tool. It's called this Uniflash. And this is from TI. And with this, I can come in here and I can say, well, I would like to program this flash on here. And I can go pick my output and I can say load image. And you can see now it's flashing. So at that point, the image has been loaded on here. I can do a verify, which I would understand as it's going to take the file and compare what's on the flash, read the flash and compare it. And it reads it back and says, yeah, it matches. So that verified fine. I'll reload it. But for some reason, when I lose power, I'm losing whatever is supposed to be there, and I don't know yet what's going on. If it's that it's now, I can do this if I turn power off and turn it back on. Let's just see if I do a verify image. And this is saying it successfully verified it. I'm going to turn it off. I'm going to turn it on without the debugger. And then I'm going to go back. And I'm going to do a verify, and then it fails. So it seems like if I try to boot this when the debugger's not there, I don't know, something happens to the flash. But even when I turn it off and on, it doesn't boot to that flash. And I think that's because the debugger's hooked up and it's saying that the debugger's in charge and not to boot to the normal flash. But when I disconnect that, I would expect it to then boot to the flash, but then at that point, something gets messed up. So if anybody has any ideas on that, drop me a note. But my road ahead of me just has some reading to do to see if I can figure out what's going on there. But nice little utility here to quickly go pick one of my compiled output files and then load it onto here. And that seems to go fine. So I think that's where I'm going to stop this video. I do have this development environment, Code Composer Studio, up and running. I am able to compile and get that onto my little dev board. I can interactively debug it. All of that's working fine. The big gotcha right now for me is that I cannot take away power and the debugger, turn it on and have it work. And that could just be there's something I'm not understanding that needs to be done yet on the programming side of it, or in a configuration on how it boots. But that's something that I'll dig into. So that's it for now. And more to come on this, because I will probably next go over to my... Well, I want to keep working with this. I need to figure out how to make that flash content stay, persist on here even with a power loss. Then I need to get that FPGA, that 256 ball CT256 version of the ICE40, see if I can get that board assembled and if that'll work. So either more on this to come, or maybe the next video might be to see if I can get that CT256 up and running.